So there it is. It looks good, and it doesn't look so good. The focus is gone. Hey guys, welcome back to the Hewlett-Packard 8568B Spectrum Analyzer Restoration Project. When we last left off, I had gotten the thing seemingly fully working, and I went through the internal calibration, and it seemed to pass all the tests, and I tweaked the few manual adjustments there are. And I left off by saying I was ordering up a few things. Well, those few things have arrived. One, a new non-rechargeable lithium battery for the CPU memory board. Two, 10 megahertz oven-controlled 10 megahertz reference oscillator. And three, a gorgeous service manual we'll take a look at in a little while. Now, I probably won't need this, not right now, but it's beautiful. I wish all service manuals were like this. It almost makes me hope that something fails on this so I can make use of it. But for sure, it's a wonderful thing to behold. Well, let me talk a little bit about this guy. So it turned out the main problem I had with getting this thing to do anything was it was missing a 10 megahertz reference clock. I should have been tipped off a little bit. I didn't do my homework enough on these devices, but I did note early on that the internal-external switch on the back was set to external. What I didn't realize is that if the clock is missing, these things are essentially dead. Now, it does have a separate oscillator on the board for the CPU, and it does run the internal checks, and they succeeded. But there is no error light anywhere on the outside that says reference oscillator not detected. Nothing on the display that says reference oscillator not detected. Which makes me think that if you did have an internal one or an external one and they failed for some reason, you wouldn't know it unless you know how these act when it's missing. Which I really think they dropped the ball on that. Unless I haven't seen it mentioned in the service manuals. Otherwise, you know, I would think on like page 1 it would say, make sure you have a reference oscillator, otherwise it's not going to do anything. A little sore about that, but we got it sorted out. Now, let me explain a little bit about that, because I don't think I did a very good job of explaining it, because I was a little put off when I discovered that was the problem. So why didn't it have one? Well, remember, these are very expensive in precision devices when they came out in the 70s and 80s, as were a lot of other pieces of Hewlett-Packard test equipment, like my 8662A, my 8664. I believe they all have on the back a reference out and a reference in. I think your typical customer for this is going to be a laboratory, and they're going to have multiple pieces of equipment. So rather than have a somewhat expensive precision oscillator inside of each one that needs to be calibrated, they would get one and hook them all together. That way they're all in lockstep with each other, they're all in agreement with each other, and you only have to calibrate one. And pay the extra money to get one really good oscillator and hook them all together. So that's probably why this didn't have one, and I suspect strongly that these shipped without them, because I've seen a couple other YouTubers work on these, and I've seen photos of other ones online. None of them had a reference oscillator. Now, I did watch Simon Spears work on his. He saved me on this project for the few things, but one of them was the oscillator, because his had basically the same problem mine did. Now, we're not out of the woods yet. I bought this from a reputable seller, and I said it works, and I don't have any reason to doubt him, but I have read other people have had trouble with these, because inside of this, there's a heating element, a thermocouple. I imagine there's an oscillator. I don't think it's just a crystal. I think this actually puts out a sine wave, and we got a power connector, so there's going to be some electronics in here. There is foam padding all around inside, and it's a type of foam from the 70s, 80s that does not hold up well over time. I've had a number of things, especially portable equipment like my CRT tester, where all the adapters are put into the lid where they have foam cutouts for each one. That foam just disintegrates, falls apart, gets everywhere, gets kind of sticky and nasty. I've heard that's what's in these. And one gentleman went so far as to have to repair his, which is tough to do because these are hermetically sealed. See, this looks like this one was glued. You have to get this open. and get inside there, remove the foam, put some kind of new foam that has similar characteristics, seal it back up, and then very likely have to calibrate it again after you monkey around inside there. Ooh, hear that? Yeah, there's something moving around in there. So, that foam may have shrunk, might not be a great thing, but I am not a precision laboratory. I don't need this to be accurate to a millionth of a hertz. If it's accurate to plus minus 10 hertz, 100 hertz, I don't think I'd ever notice, and that would be just fine with me. Because, as I mentioned when I first got this, I don't have any burning need to do any serious scientific laboratory type work with this. I want to demonstrate what they can do. I want to play around with it. I want to check out the output of some stuff. But you see, I typically work on vintage tube type stuff, TVs and whatnot, which are also not exactly precision devices. So if I'm within plus minus a percent or two, we're fine. All right, so that's the oven. Battery goes on to the board that has a static RAM on it. I think when I go through that calibration procedure, well, actually I know, it stores those values in that RAM. There are also a number of preset modes. I think there are, looks like we have 5 preset buttons, A, B, C, D, E, or maybe more. Just has shift some of these buttons to 2 functions. In other words, I think we can set up various things like a start and end frequency and bandwidth and that, and then we can save it and then recall them later on. I think when that battery goes out, you lose all that stuff. I don't think you lose anything critical like you might with some oscilloscopes. I think it's more like user-defined settings, presets, the internal calibration stuff, which is easy enough to redo. I haven't even checked the internal battery, but it seems likely because it looks like it's the original that it's bad, and they still make batteries that are pretty much identical to that, so I ordered one up. It's a non-rechargeable lithium battery. Got it off Amazon. And finally, the service manual, which I don't really need right now, other than maybe to verify the full operation of it, but man, it is gorgeous, so I want to spend a little bit of time showing you what's in here. Now, Hewlett-Packard manuals from this era are generally freely available online. In fact, I think you can download this from Agilent, which is what Hewlett-Packard's called these days. And it's a decent quality scan. And there are also people online selling reprints of this, where they've scanned it and reprinted it in a spiral bind, and they're fine, and they're great. You can get it on a CD-ROM or a DVD, whatever, and they're great. But I got to tell you, the real deal is just wonderful. For one thing, it's color versus black and white, and that really matters on some of these. I think these yellow pages are changes, and then they have these lovely tabs on the side, so there's a separate section for each module in this. Like A15 was I went with the microprocessor, so you can jump right to it. And instead of having to flip through, because the trouble I had is the scan copy, it's a PDF that's hundreds of pages, and flipping through it is kind of a drag. But also, some of the procedures are in color, particularly the signature analysis, which Hewlett-Packard came out with a special meter. It's sort of like a logic analyzer. It's meant for troubleshooting digital circuits. You can set jumpers inside of it or configure certain modes of operation and then probe it with this device. And you should get certain readings, and this helps you troubleshoot and pin down things. So if we go to A15, we'll see that. But in general, each section starts with a theory of operation, and then we have a parts list, and then gorgeous schematics, which I believe are hand-drawn, maybe some assistance, but if you look at it, some of the stuff appears to be hand-drawn. So I don't know exactly, or it is with some kind of early computer CAD type system. I'm not entirely sure, but it's really cool. And they're huge. And each module has its own, like I said, section, but also its own schematic. So you get really good detail. It's so easy to read. And aside from a few proprietary components, they generally put the values on there, so all the resistor and capacitor values are right on there. And they show you symbol, like there's even a glossary that shows you what the symbols mean for different logic gates and stuff like that. They really wanted you to be able to service their equipment. Let's get to that A15 section, which has the signature analysis stuff. Which is this. So it's this neat fold-out thing. It shows you every pad, or at least every pad that has probe-worthy signals on it. On this diagram, they're in different colors. So I believe the deal is you put it in a certain mode and you test the green test points, and the mode you test the red test points. And there are all these symbols on here. So it's +5, that means +5 volts, but then there's things like 4FCA, 6F9A, 7791. There's a lookup in here. It tells you what those mean, and it's supposed to help you pinpoint exactly what gate, what chip, what device might be bad on this. I don't have a signature analyzer. You can get them. They're floating around. Had at least one viewer offered to let me borrow one, but I don't need one yet. The downside to them is they're very much not proprietary, but geared towards Hewlett Packard test equipment. So if you're not going to work on this stuff, or you're only going to serve as one thing, it's a bit of an investment. You're probably just going to collect dust because it's not exactly a general purpose multimeter. But anyways, yeah, what a treat. And this is volume 1 of the test equipment, by the way. This is just the RF module. There's another manual for the display unit. There's a built-in frequency counter board. So it's kind of neat the way these work. So it's digitally controlled, but the oscillators are analog, the PLLs are analog. So but in order to be computer controlled or digitally controlled, it needs to know where the frequencies are at. So it has a built-in frequency counter. Alrighty, let's see about installing this clock reference. Got the bottom RF unit up on the bench, took off the bottom, and this mounts in here. So we got 2 posts in the back, 1 on the front. I don't know if it goes this way or does it go that way. Doesn't matter. I'm thinking it probably goes like this, because this connector goes down there and then the RF goes here. And one thing I've been a little unsure about is how does this go into that? Do I need to do any tinkering with this? Not sure if it's plug and play exactly. Let's see. Alright, after a bit of experimenting, tinkering, and thinking, I might just have this figured out. So, 1, we need to get this mounted. And it needs to go, well, behind this piece. So how do you do that? This piece doesn't want to come out. You can't angle it in. There's not enough room. So I got to thinking, well, maybe we can take this side off. And yes, take out 2 screws, and this carrying handle comes out, which then lets you do a little bit of finagling, slide this off. I had to take a bit of a screwdriver and give it a little bit of a nudge, and then this whole side comes off, and hey, what do you know? We have 2 screws here. So if I take these 2 screws out, this comes off. We put the oven in there, and then we remount that. Now the connector, I was confused because this was stuck on there, which looks like it's some kind of adapter. Well, if you take that off, it exposes this connector, which sure looks like it mates up very nicely with the connector on the oven. I just need to straighten out that one pin that's bent. Okay, which gets us to mounting this, because we got 2 choices. It seems it can go like that, or it can go like that. Put on our thinking cap so we can see, hey, they cut out a notch there. That probably corresponds to that adjustment. So I think it goes in like so. Which does put the RF connector up against the side in kind of an awkward place, but it do give you plenty of length. So I think that's right. Hooked up the RF output, plugged in the little power connector there. I do have to get this kind of wrapped around that mounting bracket. And then you get the 2 posts. And some mounting holes. Go. Now, put this guy here. And we go up. Yep, sure looks like that cutout was there for the adjustment screw, so I think we got it. So the big question is, how does it work? Well, we know that in the absence of this, the unit basically doesn't power up. There's nothing on the display, so I'll get the other unit up here, hook up the cables, again, power it up, and I can also take the reference out on the back of this and hook it up to a frequency counter and see what we get. Just happen to have this guy here, Kikuchi, which goes up to a gigahertz, so we should be fine with that. Alright, boys and girls, are we ready? Two units connected together, both plugged in, frequency counter going to the reference out. I did flip the switch on the back of this to internal reference position. Here we go. 10 megahertz. Okay, 10.0007. It's alive, just like that. And we have no error lights. But our oven is cold. Well, we can just let her warm up. Let's drop it down now. Here's the problem with stuff like this, calibrating it for the casual tinkerer hobbyist, if you will. I'm not a metrology lab. I don't know which is more accurate, this the way it's set, or this. None of this stuff has been calibrated recently, so, you know, for me, that's close enough to 10 megahertz. You know, if we're off by a few hertz, plus or minus, I think we'll be okay. But kidding aside, if you were going to do some serious hardcore work with this, if you wanted this to absolutely meet the specs of when it was made, yeah, you're going to need something very, very accurate. That's the tough thing about calibrating this stuff, is you need stuff that's more accurate than this to calibrate this, and where are you going to get that? That's why if you have a lab, you have somebody else do it for you, because that is very expensive equipment to maintain. I do find it curious though, as this has been warming up, it's getting closer and closer to being exactly 10 megahertz. So is this warming up? Is that warming up? Is it getting more accurate? Is it getting less accurate? We don't know. Now, one thing I could do if I had one is, if they're still broadcasting, I don't know if they are, but WWV or something like that, a shortwave station out of Colorado, broadcast with an atomic clock reference. That was way back in the day. Radio Shack used to sell clocks, and with Heathkit and others, I think they would use that as a reference to be super accurate. But yeah, how about that? Alright, let's get after that battery now. Here is the one that was in there. I just clipped it out. Made in Israel in 1990. October 1990, if I'm reading that right. So this is not the original. And you can tell that by looking at the pads. There's some flux residue on there, so this had been replaced at some point. It does still have voltage on it, though. I don't know how much power is left in it, but it's not completely dead. Here is the new one, also made in Israel, but June of 2023. We'll see how long this one lasts. Of course, I will be very careful to put it in the right way. Alright, new battery installed, easy enough. Now if you're wondering why didn't I make some attempt to hook up an external power source, why I swapped out the battery to preserve the RAM contents, because there's nothing hypercritical to the operation of this device that's stored in that RAM, unlike, say, this Tektronix 2465 scope. If that loses its internal non-volatile RAM, you need to go do some low-level calibration that requires some somewhat exotic test equipment. This is not the case. Most of what's stored in here, I believe, is the last settings you used. You can define some preset buttons, so you can jump between say start and stop frequency range, sweep rate, things like that, because there's a lot of options in this, and having to go through and set those every time you want to do a different operation is a bit tedious. And yes, it does store some calibration stuff, but that's parameters come from the internal self-calibration, which we need to redo anyways, because I just installed a new reference clock, and it's relatively easy to do. I showed that in the last video. So I'm going to put this back together, button it up. Really the only remaining issues to me right now are cosmetic. Missing a few bits and pieces. For example, this bottom unit should have feet, and all 4 of them are missing. Not a big deal the way I'm going to put it up on my workbench, but it'd be nice to have them. What's a little bit bigger of an issue is how these 2 units are supposed to mate together. So this is the bottom unit, the other unit's the top unit. On the top of the bottom unit, we have 4 of these hooks that are a little bit mangled. Those are supposed to lock into slots on the back of the top unit. I have not been able to get those to mate up cleanly yet. I think they're a little bit bent. These units are 50 pounds each. It's a little hard to finagle them. Not a huge deal. You can just put them on top of each other and leave it at that, but that's how they're supposed to lock. And once you get the fronts locked, the backs are supposed to connect together, and I'm missing that hardware as well. On the backs of these, there are threaded holes here. There's supposed to be a plastic block in each corner that goes between the top and the bottom, and you run a screw into each. So they hook together on the front and they screw together on the back. If you don't have this, the weight of the top just rests on the bottom unit, but there should be a little bit of a gap, and they should be a little more leveled out than if you just put one on top of the other. Not a big deal. Probably be rather hard for me to track down those exact pieces of plastic. 3D print, possibly, but they need to be pretty sturdy. As I said, this top unit weighs, or this guy weighs about 50 pounds, so you need something pretty heavy-duty plastic. But yeah. Beyond that, so I'm going to button these all up. We're going to run through the internal calibration. We're going to get them set up on top of each other, and then we are going to try firing up this guy. So pretend the spectrum analyzer is there in place of that porthole chassis, and the big beautiful vector monitor is on top of it. If I could switch between using it with the spectrum analyzer and using it with this 8660C2 sweep generator, which I would use for alignments, that would be a wonderful thing. Now what would it take to do that? Well, so you've got an X input, a Y input, and a Z input. The X is the sweep. It's a horizontal sawtooth. You could make a switch that would go between the sweep out on this and the X output on this. Bigger issue is the Y. So when you use it with spectrum analyzer, there's a Y output on the back of this. You hook it up to the Y input on the vector monitor. But when I'm doing alignments, the Y needs to go to, well, the device that you're testing. And perhaps an active probe, a demodulation probe. Depends on what you're working with. Now, if you use a dedicated sweep generator like for TV and radio, they have a demodulator input on it, and it adds the markers and stuff like that. This is a little bit different when you use this, because this is just an RF generator. It does the sweep, it does the RF. You don't feed the input back into this. So I would need some kind of active probe or something like that. Anyways, it's just dreaming. And then I would need to be able to switch between the Y output on this versus some type of active probe of the thing I'm trying to align. And then the Z. This also has a Z output on the back. Those would just be a simple switch like the X. But it would also not just be a simple switch. You'd be able to handle high frequencies and not add distortion or interference or anything like that. But that's the dream. That's the dream. For now, let's just get this working. Alrighty, I got the units closed back up and stacked again, and I tried once again to get the fingers to interlock, and it didn't quite happen. And see how there's a gap here and then it narrows down. That might have something to do with those fingers not interlocking. I can put a little spacer in there to get this top unit so it's level. But let's worry about that later. Right now, let's worry about this. This is my prized high-resolution Hewlett-Packard XY monitor. And I have it hooked up to the spectrum analyzer. So we are going to fire everything up right now. Got the reference going to the input, so we'll have something to see on the screen. And, well, let's see if we can make this do something. Alright, first off, let's use the light a little bit. Let's turn on base unit. Status light's good. Display's coming up. Excellent. Let's fire this guy up. It's on. I don't see anything though. It's starting to glow blue. Okay. Intensity. Try position. It's Y position. Glows a little bit more when it's kind of in the middle. Let's check X position. There it is. But it's tiny. It's the same size as that. But we have gain control. So gain X. Ooh, that's maxed out. That I was not expecting. Well, that's no good. It means we can't make it any larger than that. Y gain. Big power. Geez, do I need some kind of amplifier? It's rotated a bit too. I actually have control on the front for that, so we can level it out. Boy, that is nice looking. A bunch of geometry correction. We got orthogonal correction, and we got astigmatism, we got focus, so you can really dial it in nice. Huh. Well, short of, having to put a preamp in there, there's one thing I can do. There's a switch on the back of this for 50 ohm versus 1K input impedance. I'm in the 50 ohm position. Let's switch it to 1K. And it did nothing. Well, nuts. Well, I'll poke around the back, see if there's anything I can do to boost the gain. Now I really got to wonder, a photo I've seen where they have this filling up the whole screen, how did they do it? Not only is it super crisp, but it's blue, which is an interesting effect. Another curious thing is the photo I've seen where somebody had the setup, this was green, not blue, but I don't know if that's because they had a lens over the front that made it look more greenish, or was it actually a different phosphor type? I don't know. Oh, we're so close, so close. I was looking through the manual for this guy, and it turns out this is the impedance switch for the Z-axis. The impedance switches for the X and Y are underneath these covers. And you should be able to get a full screen deflection with just 1 volt input. I'll have to look up the specs to see what this guy puts out, but right now let's pop these covers off and see what position those switches are in. Well, I have some good news and some bad news. I took those covers off. I changed the switches for the input attenuator or input termination, and it did increase the gain, but I think I bumped a wire or loosened a connection or something, so now this is acting very strangely. I've recorded this segment several times, but each time I recorded something different happened, so I'm not entirely sure what's going to happen this time. We'll see. So what's been happening is the focus kind of goes in or out, or the brightness acts weird. but at least it's filling the screen. So there it is. It looks good, and it doesn't look so good. The focus is gone. Now, when I played around with this before, I gave up on it. I thought, well, I turned the brightness up, I'm manipulating the focus, nothing's changing, must have a bad connection. But then, see if it works now. When I carefully adjusted the brightness, so I'm going down, it's almost inverting, like the axes are black now, and if I get it just right, it actually comes back in. But we just have the grid lines. We don't have the signal. And if I go down, it just goes away. So it's acting like, just going on my TV knowledge, like the electrostatic focus signal, which has been disconnected. And I'm only going to get good focus by varying the brightness, and there's just one little sweet spot that's good. And I also have to increase the brightness and start seeing the trace, and I don't see all the text until I really go up with the brightness. But that's actually how the built-in display works too, which is kind of goofy. So let me zoom in on that a little bit. So if I turn the brightness down on this display, notice the text disappears. And if I go down lower, then we're left with just the grid. So the external monitor is acting the same way. Now, I've tried wiggling things and reseating things. I broke something. Tried doing that. I've had trouble with this before. If you watch the video where I resurrected it, I just had to reseat the cards and it came back to life. I've tried doing that. I don't know. But man, we got close. Boy, we got close. We'll get back to this. I got the full service manual. It's Hewlett-Packard, of course. It's a great tale. We can go through all that. But not right now. It's getting late. I'm going to wrap this up. I'll leave you off with looking at the built-in display. So we will start using this for projects. Try to give you a better view of it there. I'll just quickly demonstrate something I can do with this. For example, I change the frequency to 20 megahertz, which is what my reference signal in is. Now we see it right in the middle. If I change the width on that to say 1 megahertz, we're seeing a nice spike there. So one thing I can do with this, I can hook this up to the output of an RF generator, and I can see what it's putting out. Say it's supposed to be putting out 1 megahertz, and I put it on this center frequency of 1 megahertz. We can see if there's any harmonics, if there's any noise, if there's any garbage, and we can also look and see what does an AM modulated signal look like, what does an FM modulated signal look like, and so on. And we can check the output of some of these cheap RF modulators or transmitters and see what they're putting out. You may have seen me working on an AM radio, and when I put on the overhead shop lights, I hear a lot of hash noise. Well, now we can see. I can hook an antenna up to this device, turn the lights off, turn them on, and we should see some noise in here. So that's the kind of fun stuff we can do with this. That's it for now. Thanks for watching.